Huawei is challenging NVIDIA with a new chip for artificial intelligence, according to the Wall Street Journal. Huawei has reportedly told potential clients that the chip is comparable to NVIDIA's H100.
Huawei's Ascend 91C AI chip is rewriting the rules in the global tech race. Built under US sanctions, it rivals NVIDIA's H100 GPU, shaking the very foundation of NVIDIA's dominance. With projected orders exceeding 70,000 units worth $2 billion and adoption by Chinese giants like ByteDance and Baidu, this chip isn't just a product, it's a declaration of China's bid for tech independence. Huawei's journey from a small telecom equipment provider to a global technology powerhouse is a tale of remarkable growth and resilience. Founded in 1987 by Ren Zhengfei, a former military engineer, Huawei has become one of China's most prominent tech companies. However, the company's rise has been marked by controversy, particularly in its relationship with the United States. Since 2019, Huawei has been grappling with severe US sanctions that have significantly impacted its access to advanced technology. These restrictions were implemented due to concerns about national security and Huawei's alleged ties to the Chinese government. The US government has accused Huawei of potentially using its technology for espionage, a claim that Huawei has consistently denied. The sanctions effectively cut off Huawei's access to crucial American technology, including advanced semiconductors and software. This has forced the company to seek alternative suppliers and invest heavily in developing its own technology. As Huawei's founder and CEO, Ren Zhengfei, stated in a 2019 interview with the BBC,
"There's no way the US can crush us. The world needs Huawei because we are more advanced. Even if they persuade more countries not to use us temporarily, we could just scale things down a bit. And because the US keeps targeting us and finding fault with us, it has forced us to improve our products and services."
This determination has led to the development of the Ascend 910C, Huawei's latest AI chip that aims to rival NVIDIA's H100 GPU. The Ascend 910C represents a significant leap in Huawei's chip technology and demonstrates the company's ability to innovate despite facing severe restrictions. While specific technical details about the Ascend 910C are still emerging, early reports suggest that its performance is comparable to NVIDIA's H100. This is a remarkable achievement, considering that the H100 is currently considered the gold standard in AI computing. The Ascend 91C is designed to excel in crucial areas such as training AI models and processing vast amounts of data, which are fundamental to modern AI applications. One of the key advantages of the Ascend 910C is its potential availability to Chinese companies. Due to US export restrictions, Chinese firms have limited access to NVIDIA's most advanced chips. Huawei's new chip could fill this gap, providing Chinese tech companies with a powerful alternative for their AI computing needs. This could be a game changer for China's AI industry, which has been hampered by lack of access to cutting-edge hardware. However, producing such advanced chips is no small feat, especially under the constraints of US sanctions. Huawei has had to overcome significant challenges in its chip production process. The company has reportedly been working closely with Semiconductor Manufacturing International Corporation, China's leading chip manufacturer, to produce the Ascend 910C. According to sources familiar with the matter, the yield rate for the Ascend 910C, the proportion of chips that come off the manufacturing line fully functional, is currently around 20%. This is significantly lower than the 70% typically needed for commercial viability. However, Huawei and SMIC are working tirelessly to improve this yield rate, demonstrating their commitment to overcoming technical hurdles. The market implications of the Ascend 910C are potentially far-reaching. In China, where demand for AI chips is skyrocketing, Huawei's new offering could quickly gain traction. Major Chinese tech companies, including ByteDance, the parent company of TikTok, Baidu, and China Mobile, are already testing the chip. If these industry giants adopt the Ascend 910C, it could significantly erode NVIDIA's market share in China. According to the Wall Street Journal, initial negotiations between Huawei and potential customers indicate that orders for the Ascend 910C could surpass 70,000 chips, with a total value of around $2 billion. This level of demand demonstrates the eagerness of Chinese companies to access cutting-edge AI technology, even in the face of geopolitical tensions. The development of the Ascend 910C is not just a business move, it's a strategic play in the ongoing US-China tech rivalry. This chip represents China's determination to achieve technological self-sufficiency, particularly in critical areas like artificial intelligence. By developing its own advanced AI chips, China aims to reduce its dependence on foreign technology and bolster its position as a global tech leader. The US government and NVIDIA are likely to view these developments with concern. The US has been working to maintain its technological edge over China, particularly in areas deemed critical to national security. The emergence of a competitive Chinese-made AI chip could prompt further restrictions or policy changes from the US government.
So Chris, another update in the chip war as far as US versus China today with the news of Huawei building that chip. I'd be curious just sort of your takeaway here, what it means for US chip companies in China to have Huawei building this product right now.
Well, I would say, first off, we don't know much about the details of this new Huawei chip. So how good it will actually be, how many will actually be produced. We're going to have to wait and see. And a lot really does depend on those details. But I think we shouldn't be surprised that Huawei is trying to build newer and better chips, given that the Chinese government has anointed Huawei as the country's chip champion, given it all the resources that it needs to try to catch up to Western leaders in chip production like NVIDIA.
NVIDIA, for its part, is not standing still. The company has been developing new GPUs designed to comply with US export rules while still meeting the needs of Chinese customers. The H20, L20, and L2 GPUs are examples of NVIDIA's efforts to maintain its market share in China. However, striking this balance is becoming increasingly challenging as restrictions tighten. Despite the promising outlook for the Ascend 91C, Huawei still faces significant challenges. Scaling up production to meet potential demand will be a major hurdle. The company's access to advanced manufacturing equipment remains limited due to US sanctions, which could impact its ability to produce chips at scale. Moreover, there's always the possibility of further US restrictions that could disrupt Huawei's supply chain or limit its ability to sell the Ascend 91C. This uncertainty creates a complex landscape for both Huawei and its potential customers. The competition between Huawei and NVIDIA in the AI chip market is likely to drive rapid innovation in AI technology. As both companies push the boundaries of what's possible with AI chips, we can expect to see significant advancements in areas like machine learning, natural language processing, and computer vision. Industries relying on AI, from healthcare to autonomous vehicles, stand to benefit from this competition. More powerful and efficient AI chips could enable new applications and improve existing ones, potentially leading to breakthroughs in various fields. For example, in healthcare, more advanced AI chips could accelerate drug discovery processes or enable more sophisticated analysis of medical imaging data. The long-term implications of this development extend beyond just the tech industry. The ability to design and manufacture advanced AI chips is increasingly seen as crucial for national competitiveness. The outcome of this technological race could have far-reaching effects on global economic and political dynamics. As we look to the future, it's clear that the AI chip landscape is evolving rapidly. Huawei's Ascend 91C represents a significant challenge to NVIDIA's dominance, particularly in the Chinese market. However, the ultimate impact of this new chip will depend on various factors, including its performance in real-world applications, Huawei's ability to scale production, and the broader geopolitical context. The development of the Ascend 910C is more than just a story about a new product. It's an indication of the resilience and innovative capacity of companies even in the face of severe restrictions. As Ren Zhengfei noted in that same BBC interview, "The US keeps targeting us and finding fault with us. It has forced us to improve our products and services." This sentiment encapsulates Huawei's approach to the challenges it faces, using adversity as a catalyst for innovation and improvement. The emergence of the Ascend 910C also highlights the increasingly complex and interconnected nature of the global tech industry. While companies like Huawei and NVIDIA compete for market share, their innovations contribute to the overall advancement of AI technology, potentially benefiting society as a whole. However, this progress is taking place against a backdrop of growing techno-nationalism, where countries view technological leadership as crucial to their national interests. The US-China tech rivalry, exemplified by the restrictions on Huawei, is reshaping global supply chains and forcing companies to adapt to a more fragmented technological landscape. For the AI industry, this fragmentation could lead to diverging technological standards and ecosystems. While this might spur innovation in the short term, it could also create challenges for global collaboration and interoperability in the long run. Companies and researchers may find themselves working in parallel, potentially duplicating efforts and slowing overall progress in AI development. The story of Huawei's Ascend 91C is still evolving, and many questions remain unanswered. Will the chip live up to its promise and truly rival NVIDIA's offerings? And how will this shift in the AI chip market affect the broader tech industry? As we move forward, it will be crucial to monitor not just the technical specifications of these chips, but also their wider impact on the AI ecosystem, global tech policies, and international relations. The Ascend 91C may be a chip, but its ripple effects could be felt far beyond the world of silicon and circuits. For example, the success of the Ascend 910C could accelerate China's efforts to build a self-sufficient tech ecosystem. This could lead to the emergence of new software platforms, development tools, and AI frameworks optimized for Huawei's chips, potentially creating a parallel AI ecosystem to the one dominated by US companies. On the other hand, if the Ascend 91C fails to live up to expectations, or if Huawei struggles to scale production, it could reinforce NVIDIA's dominance and underscore the challenges of developing cutting-edge technology in the face of international restrictions. The implications for global AI research are also significant. If Chinese researchers and companies have access to chips comparable to those used by their Western counterparts, it could level the playing field in AI research and development. This could lead to more diverse approaches to AI problems and potentially accelerate the overall pace of AI innovation. However, it could also exacerbate concerns about AI safety and ethics. As AI capabilities advance rapidly on multiple fronts, ensuring that these powerful technologies are developed and used responsibly becomes increasingly crucial. The emergence of multiple centers of AI innovation could complicate efforts to establish global standards for AI ethics and safety. For businesses and organizations worldwide, the development of the Ascend 910C and similar chips could provide more options for their AI computing needs. This increased competition could lead to lower prices and more rapid improvements in AI hardware. However, it could also create challenges in terms of compatibility and portability of AI models across different hardware platforms. In the field of international relations, the Ascend 91C serves as a potent symbol of China's technological ambitions and its determination to achieve self-sufficiency in critical technologies. How the international community responds to this development could shape the future of global tech governance and trade relations. Whether the Ascend 910C will truly wipe out NVIDIA remains to be seen. What's certain is that it has already disrupted the market and sparked a new phase in the global race for AI supremacy. As this technological drama continues to unfold, one thing is clear. The world of AI is on the cusp of a new era, and the implications will be far-reaching and profound. China has filed a groundbreaking patent that could challenge ASML's dominance in EUV lithography, a critical technology for advanced chip manufacturing. The patent, developed by Huawei, details key components like a 13.5 nanometer EUV light source and precision mirror systems, signaling China's ambition to produce its own EUV machines and potentially break ASML's monopoly.
Today, ASML has a monopoly on the fabrication of EUV lithography machines, the most advanced type of lithography equipment that's needed to make every single advanced processor chip that we use today. And this company is one of the most extraordinary organizations in the world. The machines that they produce, each one of them is among the most complicated devices ever made.
While industry experts warn that building a commercial EUV machine could take years, this development intensifies global competition in chip-making technology, raising stakes for ASML, the semiconductor supply chain, and the geopolitical balance in tech leadership. Subscribe to the channel so you never miss our future updates. ASML is the sole global supplier of EUV lithography machines, which are essential for manufacturing the most advanced computer chips. These machines, each costing up to $380 million, are marvels of engineering. They're roughly the size of a bus and operate with atomic-level precision, representing the pinnacle of semiconductor manufacturing technology.
At the center of this big factory in the Netherlands, in the midst of a months-long assembly process, there's a revolutionary machine that the whole world has come to rely on.
You could see an EUV machine right behind me.
The size of a city bus, but working with atomic-level precision, these EUV lithography machines are the most expensive step in making every advanced microchip that powers the modern digital age. Data centers, cars, and every single iPhone.
We are the only provider on the planet of this critical technology.
These machines are the only way to print minuscule designs on these chips. They cost up to $200 million, and they're only made by a single company, Advanced Semiconductor Materials Lithography, or ASML.
EUV lithography is a complex process that uses extremely short wavelengths of light to create intricate patterns on silicon wafers. This technology enables the production of chips with features as small as a few nanometers, which are used in cutting-edge devices like smartphones, artificial intelligence systems, and high-performance computers. The process involves generating EUV light by striking tiny droplets of molten tin with high-energy lasers, then directing this light through a series of specialized mirrors and lenses to create precise patterns on silicon wafers. ASML's dominance in this field has made it not just a technology company, but a geopolitical asset. Major chip manufacturers like Intel, Samsung, and TSMC rely heavily on ASML's machines to produce their most advanced chips. This dependence has placed ASML at the center of international tensions, particularly regarding its sales to China. China has long been pushing for technological self-reliance, especially in the semiconductor industry. This drive has intensified in recent years, partly in response to restrictions on high-tech exports to China imposed by the United States and its allies. These restrictions have specifically targeted ASML's ability to sell its most advanced EUV machines to Chinese customers, citing national security concerns. In response to these challenges, China has been investing heavily in its domestic semiconductor capabilities. The country has poured billions of dollars into research and development, aiming to close the technology gap with global leaders. Chinese companies have been making strides in various aspects of chip design and manufacturing, but until now, they have struggled to match the advanced lithography capabilities provided by ASML's EUV machines. The new patent filed by Huawei, a leading Chinese technology company, marks a significant milestone in China's semiconductor ambitions. The patent details key components of an EUV lithography system, including a 13.5 nanometer wavelength EUV light source, a reflective mirror system, a lithography system, and control management technology. These are precisely the core elements that make ASML's machines so advanced and difficult to replicate. The EUV light source is particularly crucial. Generating and controlling EUV light, which has a wavelength of just 13.5 nanometers, is an incredibly complex task. It requires creating a high-energy plasma and then capturing and focusing the resulting light with extreme precision. The reflective mirror system is equally important, as traditional lenses cannot focus EUV light. Instead, specialized mirrors with multi-layer coatings are used to reflect and focus the light. The lithography system itself involves precisely controlling the movement of the silicon wafer and the mask or reticle that contains the pattern to be printed. This system must operate with nanometer-level accuracy while moving at high speeds to maintain production efficiency. Finally, the control management technology coordinates all these complex systems, ensuring they work together seamlessly to produce chips with the required precision and consistency. The implications of this patent are far-reaching. If successfully implemented, it could provide China with the capability to produce its own EUV lithography machines, potentially breaking ASML's monopoly. This would not only reduce China's dependence on foreign technology, but also position it as a competitor in the high-end semiconductor equipment market. For ASML, this development represents a significant threat to its market position. While the company has enjoyed unchallenged dominance in EUV technology, the prospect of Chinese competition could disrupt its business model and future growth prospects. The semiconductor industry operates on long development cycles and massive investments, and the emergence of a new player in advanced lithography could alter the landscape dramatically. The potential impact extends beyond just ASML. The global semiconductor industry is highly interconnected with complex supply chains and technological interdependencies. A shift in the balance of power in lithography technology could have ripple effects throughout the industry, affecting chip manufacturers, equipment suppliers, and ultimately the entire tech ecosystem that relies on advanced semiconductors. China's semiconductor industry strategy has evolved in response to international pressures and domestic ambitions. The country is taking a multi-pronged approach, combining heavy government investment, public-private partnerships, and a focus on key technologies like EUV lithography. Companies like Huawei are playing a crucial role in this strategy, leveraging their research capabilities and financial resources to drive innovation in critical areas. Beyond EUV lithography, China is also making efforts in other aspects of semiconductor manufacturing. Chinese companies are working on advanced chip designs, memory technologies, and manufacturing processes. The country is also investing in the development of its own electronic design automation (EDA) tools, which are essential for chip design. For instance, Chinese company Empyrean Technology has made significant progress in EDA tools, claiming to support 7-nanometer digital processes and 5-nanometer analog processes. Huawei has also been developing its own EDA tools since being placed on the U.S. Entity List in 2020, which restricted its access to American technology. In the field of chip manufacturing, companies like Semiconductor Manufacturing International Corporation have been pushing the boundaries of what's possible with existing technology. SMIC has reportedly produced chips with some layers at 7 nanometers, using deep ultraviolet lithography equipment and other domestic and foreign tools. The global reaction to China's patent filing is likely to be mixed. For the United States and its allies, this development may be seen as a confirmation of their concerns about technology transfer to China. It could potentially lead to further restrictions on semiconductor technology exports and increase scrutiny of international collaborations in the tech sector. On the other hand, some countries and companies might view this as an opportunity to diversify their supply chains and reduce reliance on a single source for critical technology. The semiconductor industry has faced significant supply chain disruptions in recent years, and the prospect of alternative suppliers for advanced lithography equipment could be seen as a positive development by some players. The geopolitical implications of this technological development are significant. Semiconductors have become a key battleground in the broader technology competition between major powers. The ability to design and manufacture advanced chips is seen as crucial for economic competitiveness, military capabilities, and technological independence. China's progress in this area could shift the balance of power in the tech world and have far-reaching consequences for international relations. Industry experts and analysts are closely watching these developments. While many acknowledge the significance of China's patent, there is also skepticism about the country's ability to quickly turn this intellectual property into a working, commercial-grade EUV machine. Developing such complex technology requires not just theoretical knowledge, but also years of practical experience and a sophisticated supply chain. Dr. Sarah Chen, a semiconductor industry analyst, notes, "The patent is a significant step, but there's a long way to go from patent to production. EUV lithography involves incredibly complex systems integration. It's not just about having the individual components, it's about making them work together with the precision required for advanced chip manufacturing." Technical challenges abound in implementing EUV technology. The creation of a stable and powerful EUV light source, the development of ultra-precise mirrors and optical systems, and the integration of these components into a reliable manufacturing tool are all formidable hurdles. China will need to overcome these challenges to turn its patent into a viable commercial product. Predictions about the timeline for potential Chinese EUV machine development vary widely. Some optimistic estimates suggest that China could have a prototype within 3 to 5 years, while more conservative analysts believe it could take a decade or more to develop a machine competitive with ASML's offerings. While China's progress is noteworthy, it's important to maintain a balanced perspective on the situation. ASML has not been standing still. The company continues to innovate and improve its technology, with ongoing research and development efforts to enhance the capabilities of its EUV machines and develop the next generation of lithography technology. ASML's expertise in this field is the result of decades of research and billions of dollars in investment. The company has built a deep pool of knowledge and experience that will be challenging for any competitor to match quickly. ASML also benefits from close collaborations with its customers and suppliers, creating an ecosystem that continuously drives innovation. It's also crucial to understand that semiconductor manufacturing involves much more than just lithography. While EUV machines are a critical component, they are part of a larger, highly complex manufacturing process. Success in the semiconductor industry requires mastery of numerous other technologies and processes, from chip design and materials science to packaging and testing. The semiconductor landscape is evolving rapidly, with new technologies and approaches constantly emerging. Beyond traditional lithography, innovations in areas like advanced packaging, new materials, and novel computing architectures could reshape the industry in unexpected ways. Both ASML and Chinese companies will need to navigate these changes to maintain their competitive positions. The filing of this patent by China represents a significant moment in the ongoing technological race, but it is just one chapter in a much larger and more complex narrative. The coming years will reveal whether this development truly marks a turning point in the balance of power in semiconductor technology, or if it will be remembered as just another step in the long and winding road of technological progress. For policymakers around the world, this situation presents a complex challenge. They must balance the desire for technological advancement and economic competitiveness with concerns about national security and the protection of intellectual property. The decisions made in response to these developments could shape the future of not just the semiconductor industry, but the broader technological landscape for years to come. In the meantime, companies across the tech sector are likely to be reevaluating their strategies and supply chains in light of these developments. The potential for disruption in the semiconductor equipment market could lead to new partnerships, investments, and approaches to technology development. For consumers, the long-term impact of these changes could be significant. Advancements in semiconductor technology drive improvements in the devices and services we use every day. A more competitive semiconductor equipment market could potentially lead to faster innovation and more affordable technology products. The story of ASML and China's semiconductor ambitions is far from over. It will continue to evolve, bringing new challenges, opportunities, and surprises. As it does, it will serve as a fascinating case study in the intersection of technology, geopolitics, and economic strategy in the 21st century. The semiconductor industry is in chaos, and Huawei's EUV patent filing is the catalyst. Huawei, the Chinese telecommunications giant, has recently made a groundbreaking move that has stunned the semiconductor industry. The company has filed a patent for extreme ultraviolet EUV lithography technology, a crucial component in the manufacturing of advanced chips. This development has significant implications for the global semiconductor market, particularly for ASML, the Dutch company that currently holds a monopoly on EUV lithography machines. EUV lithography is a cutting-edge technology that uses extremely short wavelengths of light, around 13.5 nanometers, to create intricate patterns on silicon wafers. This process enables the production of smaller, faster, and more energy-efficient semiconductors, which are essential for the development of advanced electronic devices such as smartphones, computers, and data centers. The importance of EUV technology in the semiconductor industry cannot be overstated. as it is the key to unlocking the next generation of computing power. ASML, the world's largest supplier of lithography machines for the semiconductor industry, has been at the forefront of EUV technology development for over 2 decades. The company has invested billions of dollars in research and development to create the world's most advanced EUV lithography machines, which are capable of producing chips with feature sizes as small as 5 nanometers. ASML's dominance in the EUV market has been further reinforced by the fact that it is the only company in the world that manufactures these machines. However, ASML's position in the market has been challenged by recent US export controls, which have restricted the company's ability to sell its EUV machines to Chinese customers.